Well, one reason I really like working for a glass company is because of what glass can do. Glass is a truly remarkable material. It shares attributes of liquids, including its transparency, and yet it behaves as a solid, as an elastic solid. And one of the most amazing things of glasses, one of the applications of glasses that was really new to me, my background's in geology, what did I know about glass? But glasses have this ability to operate in both the so-called passive mode and an active mode. So passively is it simply stays there in position and transmits light, and we use that, Schott uses that in a variety of ways. We use that as lenses, we use that for prisms and for simple windows. But things get very interesting when you start to dope glass with things like rare earths, like neodymium and erbium. And there, the light that passes through it starts to interact with the material, and the material takes on an active role. And there we can use that to make lasers out of it. In fact, one of the world's most powerful laser now, Lawrence Livermore National Lab, is made from laser glass, some of which Schott made. And this balance between active and passive combined function of glass in the same system is something that's a very challenging and yet it's ultimately a very rewarding thing for a material scientist to be involved in. So laser glass is the ability, laser material in principle, or in its ultimate function, is the ability to amplify the light that passes through it. Normally you would start with a pulse of light. It can come from another laser. It can also come from just flash lamp, and then the material itself will amplify the light, just as an amplifier for sound amplifies sound, makes it louder and so forth. Laser glass will amplify the light to make it more intense, but will also do so in a special way that the light that leaves the laser material is spatially coherent, that is, it's narrowly confined, and also its color is essentially pure. It's essentially the purest color that we know how to make, of an exact certain frequency from visible, ultraviolet, and infrared. And you can do so many different things with it. Lasers have revolutionized many different fields, and laser glass made by our company and many others have led the revolution in many ways. We could make little pieces that are a couple centimeters long, little tiny rods, sometimes even smaller than that, to things that are used for the very large aperture, high energy lasers for science and technology that are nearly almost a meter wide and by half a meter in diameter, really, really thick slabs. And that's part of what you can do with glass. You can make high quality glass parts bigger than you can make most single crystals. And so there's a threshold above which, if you get optically transparent materials, you can make glass larger than pretty much any other material. And for certain lasers, it's absolutely essential. Schott works, we have about 7 different business segments. It changes depending on the economic climate, of course. Schott is involved, of course, its heart has always been advanced materials, ultimately is optical glass that really is the founding of Schott. And that still remains an important business, not the largest part of the business, but strategic business. Schott is active in pharmaceutical materials, both syringes and tubing, or tubing for vials. Schott is active in solar energy in 2 main ways, for both photovoltaic and solar thermal means of generating electricity, and that was a very smart move by Schott several years ago to get into that. Electronic packaging, used for, among things like airbag igniters, in which you need to insulate say a metal pin from a casing, and glass is ideal for that, and so that remains an important business as well. So it's pretty wide-ranging. One of the few things that the average consumer might see the Schott name on the flat panel cooktops, and that's Schott, among some other companies make that, and that takes advantage of a unique technology of these so-called low thermal expansion glass ceramics. Glass ceramics are a kind of a mix between the crystal world and the glass world, in which we take a glass and crystallize it under controlled circumstances with prescribed chemistry, and you get some really amazing properties from that. Solar is it's quite demanding, both in terms of the technology. The technology's been around for many years, but now it's being ramped up on a really big level, and so now one talks about volume manufacturing, that probably only until recently has really been stressed. Schott is involved both in the procurement and development of the silicon modules, as well as something that Schott does particularly well, and that's with glasses involved with that, both for cover glasses, but also for the photovoltaic part, but for the solar thermal form of energy generation, in which sunlight is focused via parabolic troughs onto a tube that absorbs the energy, and inside the tube is a heat exchange fluid. And this tube has to be kept in a vacuum environment, and the tube, of course, is made of glass because it has to be transparent, it has to be hermetic, and it has to have an extremely long life. And there's a lot of things that have to be done on a technological level to make that successful, and successful for many, many years. There is a very large solar thermal, there's several large solar thermal fields around the world. A very large one is in the Mojave Desert in California, a place that I visited almost by accident recently. So you drive in the middle of the desert, you see these enormous facilities, several square miles, with these enormous parabolic troughs, and you can get an idea from the scale of the desert in which this thing resides. We're just tapping a tiny little bit of the potential of collecting energy from the sun.